true precision robotics and revolutionising aerostructure manufacture. Let's find out how.
We've taken a traditional process, which is done by hand today. Our customers can't afford to automate it. We've managed to robotise the process fully at the tolerances they require at the price that they can afford.
Music to their ears, but also exceeding tolerances as well, I understand.
Yeah, absolutely.
We'll come to that in a minute though. What's the process at the moment?
Typically today, it's all done by hand. You take a fixture and a guy would take some components that have been pre-drilled, load them into the fixture, temporary fasten them, add some more parts, on and on and on.
How long will that take to actually manufacture then?
At least a day.
At least. Okay. And how long does it do with your new process?
Just over half an hour for the actual process.
Okay. And the next step, it's not just about drilling a hole and chamfering, because it's quite specialised as well, is that correct?
Yeah, absolutely. So today, if you're doing countersinking by hand, you would drill a little bit, back off, measure, iterate, because you can't go too deep. What we've developed is a system that allows us to get an absolute reference to that surface to countersink. Now, we've had some tolerances from our customers to do that, plus minus 40 microns, and we're way within that. It is disruptive. It is very different from everything else that's out there. The competition have much larger robots, much heavier drills, they take more energy, they're less flexible, and they cost a lot more money.
Right, and when you say less flexible, in terms of you just have the drill on that robot and that's it?
No, one of the most common deployments is what's called a multi-function end effector, because they can't get the robot to go to the same place twice at these high precisions. So on a single visit, they do everything they can. So they drill the hole, they fasten the hole. Now, in some applications, that's the right thing to do, but you are stuck with it because they can't split that process up. Because it's a much smaller robot, it's taken about half the energy, and because of our guidance and machine learning, we never put a hole in the wrong place. So it's an absolute zero waste system.
The drilling process, as I've mentioned, is patented by yourself. It's your own technology. The scanning, metrology side of things is more off the shelf, but you've adapted it to go on your robot?
Yes, we've developed this scripting language that will connect any PC-based process to a robot. And what we do is we connect a metrology system with an analysis software system and a robot. So it's a really simple, quick to plug everything in together solution. It's not a whole pile of bespoke automation.
So once you've done that, you're drilling, you're chamfering, you're scanning, you can bring it all together right from the initial stage, the CAD, and then get a full inspection report and then feedback to the designer as well?
Absolutely.
I think we're just going to have a look at that.
What you're seeing on the screen is where the drill is in space with respect to the fixture. And what we've done is we've taken a robot program, created offline, put it into the robot and created an absolute digital twin. So the robot's going to a position and we have a metrology system that's guiding it to the right place. When we're in the right place, the screen goes green and starts the drill cycle. But what we've also done as part of our patented technology is we add on a machine learning level, which is taking into account the compliance of the robot during that process. So we're not putting the clamp on and then finding we've moved it out of position, take it away, iterate, we go straight in, drill the hole.
Okay, but key to what you're saying there is two things. It's your software that's doing that and keeping it, well, true position.
Yeah.
And it's not actually clamping onto the aerostructure as such.
No, we have a servo-controlled system with force feedback that goes into the product and makes a gentle touch clamp. It's just enough force to stop the drill skidding around on the surface. Okay. But with all of that servo control, we get an absolute reference for the countersink control. So all the mechanics are calibrated at a micron. We're not countersinking at a micron, but that's the resolution we get down to for the servo control. So the customer is looking for plus minus 40 microns on most of the holes. It depends on the size of the hole. And we are very centralized. We had a CPK of 4.5 and we're well within that. It's very centralized. So we're nowhere near the edges of that plus minus 40 microns. You can put our clamping technology on any third-party drill. So if somebody wants to do bigger holes with a bigger drill, our technology supports that.
Have you actually integrated this technology anywhere?
Absolutely. The system you see around us is a project called ADDI, Automated Drilling and Inspection. It was a grant-funded project from the Aerospace Technology Institute and Innovate UK, and it involved a number of end customers, so Airbus, BAE Systems, GKN Aerospace, and on the machine integration side, FANUC UK.
Your software then brings it all together, so from initial CAD, machining, inspection, to final analysis, and then it can feed it back to the designer?
Absolutely. We're trying to make maximum use of information within an enterprise. So we take information into our robot simulation from multiple sources, create the robot program very simply and very efficiently. What we're doing with inspection is not just post-validation. We're using the scanner through the build process to make sure that everything's built correctly, but the final results of that are published throughout the enterprise, and so the designer can see the actual results in production, helps their learning and knowledge for future products, or can be used as part of a continuous improvement program.
Okay, so they can take that and maybe they've over-toleranced something as an example.
Absolutely.
Absolutely fantastic process, the whole thing. So a few key things from this process.
The first thing is we're achieving all the end customers' tolerances, build requirements. The second thing is we're doing that with affordable automation so they can afford to deploy it. And the third thing is part of a net zero build philosophy. There's no waste, we don't put holes in the wrong place, and we're using lightweight, low energy robots.